This time of year, lakes and rivers and other water bodies are still relatively warm, at least compared to the cold air that's starting to take over. When unseasonably cold air enters the lower 48, as has happened several times this month, you can get some unusual weather that forms via a familiar process, and with some new higher resolution satellite imagery available, we now have more sophisticated tools to observe it. First, a review of the chill. The blue dots in this animation identify places that broke, tied, or came within a couple degrees of breaking daily or monthly low temperature records last Tuesday, Wednesday, or Thursday. And I suspect you will recognize the process that this unseasonable chill promoted in this survey of visible satellite loops of the Great Lakes. Lake effect clouds and snow, cold air moving over relatively warm water, leading to roiling streets of clouds that often dump snow on the leeward side of the lakes. Here's a close-up of Lake Superior, first in the standard visible imagery, then in a specific infrared wavelength that highlights clouds tall enough to have a lot of ice, an indication they're capable of producing heavier snow. And finally, a similar product called the Day Cloud Phase Distinction Band. The clouds enhanced in yellow here were the dominant bands that dumped 5 to 10 inches. Farther west, a different infrared band called the Nighttime Microphysics RGB that's good at detecting low clouds at night was able to distinguish lake effect clouds produced by a smaller body of water, the still unfrozen Fort Peck Lake in Montana, with less than 5% the surface area of Lake Erie. Here, clouds are yellow, the lake in blue in the middle, the air bitterly cold in the minus teens on the morning of November 11th. The next day, even the winding Mississippi River got in on the act. Waters were still in the 40s, air temperatures in the teens. That contrast enhanced these narrow cloud bands that formed on cold northerly winds, helping to produce rare river-enhanced snow flurries in downtown Memphis, Tennessee. And the next day, those northerly winds were ideal for producing clouds over both Chesapeake and Delaware bays. These bay effect cloud plumes were fueled by the temperature difference between waters still in the mid-50s and air temperatures in the 20s and 30s. Because these bays are fairly narrow and require very specific wind directions for the process to work, the clouds aren't able to grow as tall as over the Great Lakes, but radar did pick up a band of bay effect snow off the Chesapeake, and brief periods of light snow were observed at Oceana Naval Air Station in Virginia Beach. Farther north, the cloud-making factory was in overdrive as vast stretches of the Atlantic lit up with ocean effect clouds as the cold air poured off the continent over relatively warm offshore waters. We're really still near the beginning of lake effect snow season. Is any in our future? Stay tuned. The extended forecast is next.